Welcome to Construction Math. Today we're going to learn how to create and solve equations and inequalities, in other words, the dreaded word problems. So for bell work, think about the last time you had to use math to solve a problem. What operations did you have to use? Did you have to add, subtract, multiply, square, take a square root? Did it come with a worksheet? And I think the answer to that question is no, it didn't come with a worksheet. So discuss with your partner what you used to do, what you had to do the last time to solve a word problem or a math problem, and then teacher pause the video and then call in non-volunteers. Welcome back. For the math check, let's make sure you can really solve equations and inequalities. So on your note taker, please go ahead and solve these two problems. Teacher, please pause the video until the students have had a chance to, 1, solve the problems, and 2, compare with their partners. Call on some non-volunteers, and I'll meet you back here in a minute. All right, let's go ahead and welcome you back, and let's go to our slates and see if we can work these problems. All right, so the first problem said 2x minus 3 is equal to 7. Here I have multiplication, here I have subtraction. I always get rid of the lower operation first, so the opposite of subtracting 3 is adding 3. What I do to one side, I do to the other. These are inverses, so they cancel, so we get 2x equals 10. This says 2 times x equals 10. The inverse of multiplying is dividing. These cancel out because they're inverses, so I get x equals to 5. Let's just check in our minds. 2 times 5 is 10. 10 minus 3 is 7. That one worked. Now let's look at the second example. The second example was an inequality. We have to remember when we solve inequalities to please remember if you multiply or divide by a negative, you have to flip the inequality. So again, we have multiplication here and we have addition. The inverse of adding 2 is subtracting 2. What we do to one side, we do to the other. So we get 3x is greater than 15. The inverse of multiplying by 3 is dividing by 3. So x is greater than 5. Never had to flip anything because no negatives appeared. So let's see if this is true. 3 times 5 is 15, plus 2 is 17. The number has to be greater than 5, so I need to pick something like 6 or 7. So let's try 6. 3 times 6 is 18, plus 2 is 20. It works. It works. So we've checked those, and my check on the second one was a little rough, but we got through it. So let's clear that off. Let's go back to our PowerPoint, and let's look at today's objectives. There's my answers worked out. We matched. So on your note taker, fill in the missing words in red. Number 1, define vocabulary. Number 2, explain the steps for creating and solving word problems. And 3, we're actually going to create and solve word problems. So I know that 3 is probably going to scare you the most, but don't be worried. We'll make it as easy as possible for you. All right, let's move on. All right, the one vocabulary word we need today is the word equation. You're probably familiar with it, but on your note taker, an equation is a statement of inequality between 2 or more quantities, and you always use an equal sign. So fill in a picture, a meaningful sentence, and a definition in your own words. Pause the video and share with your partner your meaningful sentence. Teacher, call on non-volunteers, and I'll meet you back here in a minute or two. Welcome back. Why do we need to solve word problems? All right. The first reason is mathematics was really developed over the years to solve real-world problems. It just didn't drop down in the form of a book with tons and tons and tons of problems. People needed to use them to solve real-world problems. You may never come across problems exactly like the one in the textbooks, but you will need to deal with technical material in a written form. A lot of jobs will expect you to be able to take some information and then solve a problem. And it does not come with a worksheet with a problem already worked out just like it. 3, it's highly unlikely you will be presented with an equation to solve in the work world. When my boss has me do some work with math, I always need to figure out the equation myself. All right, so fill in the missing words. And what I want you to do is highlight any important information. That's the most important thing when you're going to do either solve word problems. You need to find out what's important and what's not. Sometimes in word problems, they give you things like, it was a beautiful sunny day and the little girl had on jeans and a red t-shirt and had bows in her hairs as she walked to the Circle K to buy a Thirst Buster, or as they call them now, Polar Pops. And she had a $1 bill and she bought a Polar Pop that cost 93 cents, including tax. How much did she get back? We really don't care about the day, what the weather was like. We don't care about what she was wearing. We don't care about that she had bows in her hair. We don't care that it was a Circle K. All we needed to know was that she had $1 and spent 93 cents. So, translating from English to math, that's what makes it hard. It's not the math that's usually hard. It's taking those English sentences or paragraphs and converting them to math. So the first thing I want you to do is take a couple minutes and think about words you know that mean those operations of addition, subtraction, multiplication, and division, and write them down on your note taker. Real quick, do 2 for each one. Pause the video until students have completed that, and then we're going to use this in just a minute. Welcome back. Now what I want you to do is get a vertical line down a clean sheet of paper or the back of your note taker if there's one free. You write down your ideas for adding, subtracting, multiplying, and dividing. You're going to do that in the left-hand column. What you're going to do is get up and you're going to rotate and get ideas from other people and add it on the right-hand column. Teacher, take about 3 to 5 minutes to do this activity and then have the students share out to you. Pause the video until you're ready to come back. Welcome back. So let's see how you did and what you got. Now for these 6 terms, sum, less than, longer than, doubled, per, and combined, they're all English terms, but now you have to convert them to the language of math. Which ones mean add, which ones subtract, which means multiply, which means divide. So take a minute on your note taker, fill those terms in, and add the operation. When you finish, compare with your partner. Teacher, when they're finished, call on non-volunteers. So go ahead and pause the video now. Welcome back. Let's go and check our answers. Sum means to add. Sum actually by definition is the answer in an addition problem. Doubled means to multiply, and specifically it means to multiply by 2. Less than means to subtract. Per means divide, longer than means subtract, and combine means add. How did you do? The most difficult ones in word problems are the subtraction and division because they're not commutative. In subtraction and division, order matters, where in addition and subtraction, order doesn't matter. If I take 3 plus 5, it's the same answer as 5 plus 3. But if I take 5 minus 3, it is not the same answer as 3 minus 5. So we've got to be really careful when we have subtraction or division. So here are the steps for solving a word problem, and I use the letters solve. So first, you need to state the problem. Luckily, most times it's written out, but sometimes somebody will give you a verbal problem. O stands for figure out what operation or operations to use. Do we need to add, subtract, multiply, divide, square root, square? What do we need to do? L stands for limit the information to what's only important. Get rid of anything that's extra. We don't care about people's names usually unless there's more than one person. V stands for variables and what they represent. So you're going to say X equals the number of gallons, X equals the number of dollars, X equals the number of miles, X equals the number of feet. And you can use visual aids like pictures or diagrams. If you can draw a picture that helps yourself, all the better. And E stands for finally, make an equation and solve it. Remember, in real world problems, you should label your answers. So fill in the missing terms on your note taker. Once students have done that, teacher, start the video up again and I'll meet you back here. Remember that a picture is worth 1,000 words. So if you can draw a diagram or a sketch, it's probably going to help you. Right? So hints for solving word problems. These are some things that have helped me over the years become more successful in word problems. Number one is read the problem carefully. I can remember when I was teaching in Flane Wells, I taught pre-calculus and calculus, And I remember assigning a word problem to my students, telling them that they had a couple of minutes to try to work on it, and then we'd talk about it together. And a student came up within 30 seconds and said, I don't know how to do this. And I said, well, what does the problem say? He goes, I don't know, I didn't read it. Well, try reading the problem first. It might be helpful to you. Second thing is identify what's unknown and assign a variable to represent them. What do you want to find? Number 3, represent all the variable or all the unknowns in terms of just one variable if possible. If I say that I have 2 pieces of wood, one is twice as long as the other, I'd make x equal to 1 piece and 2x equal to the other. Number 4, analyze the problem, draw a picture, and construct anything you need necessary to form an equation. 5, solve the problem, the equation, showing all your steps, and label your answer. Check the solution if it's possible to check, and make sure you answered the question. Too often people will get an answer, what x equals, but it will ask you something different. I know I was giving a test here at JTED to some students, and they needed to use the Pythagorean theorem, but the problem asked how many feet did they save. They found the answer of the hypotenuse, but they never answered my question. And don't give up. Always try something. And on these tests and on the final, I'll give you credit for just trying something as long as it's reasonable. All right, so what I want you to do is write down these hints in your own words and star the hint that seems like it would be the most important for you. So teacher, pause the video and give the kids a couple minutes to do this. Welcome back. Let's go on. All right, here's what it looks like in math. I've got some simple sentences. And it says a number plus 20 equals 35. A number plus twice the number equals 40. 60 fewer than a number is 80. The sum of 2 numbers is 40. One of the numbers is 10 larger than the other. So let's go to our slate and see about making equations for this. All right. So the first one says, let me get back on my slate, a number, and I'm going to just use the hashtag as a number sign, plus 20 equals 35. So the first thing I'm going to do is I'm going to let x equal my number. You can pick any variable you want. If you want t, if you want a, as long as you write down what it starts with. Now a doesn't mean anything except it's referring to that we only have one of them. So the number is x, plus means addition, 20 equals means put an equal sign, and 35, and there I made the equation. That's all I want you to do now. We don't have to solve anything. So let's look at the second one. The second one says a number plus twice. So be thinking what twice means. Twice the number equals 40. I'm going to continue to use this for all my problems. So here we go. A means 1, number is x. Plus, when I think of twice, I know it tells me 2 things. It tells me it's multiplication. It also tells me I'm multiplying by 2. Plus twice, so I'm going to do 2 times the number is x, equals to 40. And there I wrote it as an equation. That wasn't too hard. The next one says 60, and I know it was in words, but fewer than, let's get the rest of the sentence, a number is 80. All right. Now, before I start writing this, I saw that fewer means subtract, but fewer than tells me something else too. Because remember a couple minutes ago, I told you that subtraction is not commutative. Order matters. So I need to know which one of these goes first. Does the 60 go first or does the x go first? When it's fewer than tells me that the order switches. So this is x minus 60 is equal to 80. So fewer than me is very different than fewer. If this just said 60 fewer a number is 80. this would be what it looks like. It would be 60 minus x equals 80. That than word in English is very powerful. So be very careful when you come up to it. All right, the last one says the sum of two numbers is 40. It said one number is 10 greater than, or it said larger than the other. So I think I'm going to take this second sentence to help me with my variables because I know I have two numbers. So something's going to equal one number and something's going to equal the other or the second number. Now it says 1 is 10 larger than that. So I'm going to let this one be the smaller number. The second number would be x plus 10 because it's 10 bigger. Now I've used this piece of information once. I don't want to use it again. Now I go back. The sum means to add of the two numbers. One of my numbers is x. One of my numbers is x plus 10. And it says it's equal to 40. And there's my equation. Wasn't so bad, was it? So pause the video if you have any more questions or needed a little bit more time to process. And I'll meet you back here in a minute. Welcome back. Let's clear this out. Let's go back to our PowerPoint. Now, oh, there's our answers. Looks like we got them all right. Yay. All right, now here's what we need. On your note taker, fill in the missing numbers and the missing words that are in red. And it says your crew needs to move gravel from the front of the house to the back of the house. When the total number of wheelbarrows full is added to its sum, its sum is 970 loads. One of the crew moved 530 loads. The other two crews move loads that are equal to each other. Find the number of loads the other two crew moved. All right, so what I want you to do first, I know it's kind of confusing, is just to go back and highlight what's important. Pause the video, have students compare what they highlighted, and I'll meet you back here in a minute. Welcome back. Let's see what I highlighted. I highlighted what was in red. All right, first for me, total number of wheelbarrows full is added to find the sum of 970 loads. That was all important. Also, too, one of the crews moved 530 loads. The other two crews moved loads that are equal to each other. Those were the important things. And then in blue, I put what I want to answer. Find the number of loads the other two crew moved. Because we knew one of the crew moved 530. So let's go to our slate and let's take a look at this. All right. So let's say that x is going to equal to the number of wheelbarrow loads, and I'm just going to call it loads, the other crews moved. On your test, if you put x equals the number of loads, I'll be fine. All right, so I know. First of all, one of the crews moved 530 loads. All right, then we're going to add some other loads. The other two crews added the same, or took in the same amount. So they're both going to be x, and the total number of loads was 970 loads. So one crew did 530, the other two did what was equal to each other, and it had equal to 970. So I need to solve this. Now here's an equation where I had like terms. X plus x gives me 2x. Just like an apple plus an apple gives me 2 apples. $1 plus $1 gives me $2. Plus 530 equals 970. Now subtract 530 from both sides, because that's the inverse of adding 530. So let's be careful on my arithmetic. Let's see what we get. 0 take away 0 is 0. 7 take away 3 is 4. 9 take away 5 is 4. All right. Now, 2 times x, the inverse is dividing by 2. So x equals 220. And I'm going to label it loads. Let's check. If the first crew moved 530 and the other two crews each moved 220, let's see if that really adds up to 970. 0 plus 0 plus 0 is 0. 3 plus 2 is 5 plus 2 is 7. 5 plus 2 is 7 plus 2 is 9. Yep, it added up properly. So what we needed to know was that each of the other crew, and let's put up the equal crews, each moved 220 loads. So once I got rid of what wasn't important and I got it set up, the math actually was really fairly easy. All right, pause the video if you need to, and we'll go back and meet you back here in a minute. Welcome back. Let's go back to our PowerPoint. Let's see if I worked it out. Oh, I did, and I got the exact same answer. Yay. All right, now example 2. It says the construction sites have a total of 80 hammers, and one site has 48 fewer hammers than the other. How many hammers does each site have? So first step is to highlight or underline what's important information. Make sure you catch words that have to do with operations. Pause the video, have students compare with their partners, and I'll meet you back here in a minute. Welcome back. Let's see if you highlighted what I did. Almost everything in this problem was important. We have 2 sites, total of 80 hammers. One site has 48 fewer hammers than the other. And in blue, I put what I'm going to solve. I need to find out how many hammers does each site have. So I'm going to need 2 answers when I get finished. All right, let's go to our PowerPoint, or to our slates, and see what we can come up with. All right, so here's what we're going to do. We're going to look at this. I'm going to just pick one of the sites. X equals one site. Let's do it grammatically. One site's number of hammers. And then it told me that there were 48 hammers. Well, if this site had 10, the other one had 38. If this site had 20, the other site had 48. How I was getting that is I was taking 48 minus the number of hammers at the first site, giving me the numbers of the hammers at the second site. So that's what I'm going to do here. Then 48 minus X equals the second site's hammers. Now they told me that there were a total of 80 hammers. So that'll be X is one side, 48 minus X is the other side, and it equals to 80. All right, you set it up. We're good. All right, let's go back to our PowerPoint. And I want to put them up. There we go. And now, with this one, we're going to solve. So here we go. Example 3. A foreman has 3 stops on his route. The total length of his route is 650 miles. The largest leg is twice the smallest and 100 miles more than the other leg. Find the lengths of all 3. So step number 1, highlight or underline the important information. Teacher, pause the video until we've done that. Welcome back. Let's see if you highlighted what I did. Almost everything was highlighted. I didn't care it was a foreman. It could have been a laborer. It could have been your mama. And then, so here. Now, next step I want you to do is I want you to pick out the variables and set them up. All right. So let's go to our slate. Clear that out. So here's what we're going to do. Let's let X equal the shortest leg of the trip. It's usually easiest if you do let X equal to the smallest. Now, it said in my problem that the largest leg is twice the smallest. All right, so twice means to multiply by 2. That's going to be the largest. Now it says, and 100 miles more than the other leg. So then the other leg is going to be 2x minus 100. So this is going to be the third leg. Now, what the problem says is the total length of the route was, let me go back and get it from my notes, 650 miles. Will you set up an equation that would represent this information? Pause the video until everyone's had a chance to come up with an equation. Welcome back. Let's see what my equation is going to look like. The first leg was X. The second leg was 2X. The third leg was 2x minus 100. And it totaled to 650 miles. Check to make sure you got it right. Remember, your next step is going to be to add like terms. So let's go ahead and have you pause the video and solve it. Remember to label, and the label should be in miles. Welcome back. Let's see. I'm going to go through here and I'm going to add my like terms. An x plus 2x is 3x plus 2x gives me 5x. So I have 5x minus 100 equals 650. The inverse of subtracting 100 is adding 100. So I get 5x equals 750. Let's divide both sides by 5. So x equals 5 into 750. Goes once. Subtract, bring down. We get 2. And then 5 goes into 0 is 9. So the shortest leg is 150 miles. And it would be helpful if you came back up here and put it by your legend, but that's not always necessary. Now the second one said it's 2 times x. Well, now I know x is 150. So 2 times 150 would be 300 miles. So this leg was 300 miles. Now the last leg was 2x minus 100. 2 times 150 is 300, minus 100 is 200. So this leg was 200 miles. Let's check to make sure that they added up. 150 and 300 is 450 and 200 is 650. We got the answer right. So pause the video if students need to finish copying this example, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint, and let's see. Oh, we got it right. Yay. Now this one is example 4, and you're going to work with your partner on this. So first of all, a construction foreman is computing the length of a cement slab, and I have a picture there. It's a rectangular slab. So the area is 500 square feet, and the width is 20 feet. Find the length. So the first thing you need to copy down is the right formula. Area is equal to length times width. Next thing is you're going to solve it with your partner, select the variable, set up the equation, and solve. Remember to label. And I'll meet you back here in a couple minutes, so pause the video until they're through. Welcome back. Let's go to our slates and look at this problem. All right, because it was a formula problem, I'm always going to put down the formula first. So area is length times width. It told me in my problem, I know that the area is 500, and it was 500 square feet equals to. The length, I don't know. That's what it wants me to find, but the width was 20 feet. So in this case, I didn't really need to pick variables because here all I had to do is substitute into my formula. Now to get the length all by itself, I'm going to divide both sides by 20 feet because that's the inverse of multiplying. So mathematically, I divide 20 into 500. I go 2 times, which is 40. 20 into that goes 5 times, so I get 25. Now I've got to look, what does square feet mean? Square feet means feet times feet. That's divided by feet. And this is just like in the unit conversion. Feet cancel with feet and just leave me a variable or an answer of feet. So the length is 25 feet, which makes sense. But I wanted to show you why it was. So double check your answer with mine. And let's go back to the PowerPoint. Let's delete that, go back. Let's see if we set it up. Here we go. We substituted into the formula. Formulas usually make things a lot easier. We found the information that was important. And now we're ready for closure. In 1 minute, write down the key points of today's lesson. Teacher, pause the video, and I'll see you back here next time.